Alright, so just to summarize what we talked about, the mean, I talked about it a little bit. It's where you add up all the numbers. I didn't talk about how to actually find it. I just talked a little bit about it and what it's affected by. Sum of all data divided by the total. Okay, so if you add up all the data and then you divide it by the total, you should get the mean. The mean or median, you have to be very careful which one you use. So, for example, because the median considers only the order of the values, it is resistant to values that are extraordinarily large or small. It simply notes that they're one of the big ones or one of the small ones and ignores the distance from the center. Okay, in other words, outliers. Median is very resistant to outliers. Mean, not so resistant, because since you're adding up all the data, okay, you're summing up all the data. If you have a really big number and then several hundred small numbers, they're going to appear very skew with what your data is because of the actual setup of the data. Okay. Now, I did say that when you get mean and median equal, then that's magical, and you want to keep that as close as possible. That's what we call normal. Okay, now how do we know which one to choose? If the histogram looks symmetric and there are no outliers, we prefer the mean. However, if the histogram is skewed and has outliers, you're better off with the median. Okay, and so you just want to be careful how you work with it and stuff, and you want to know about the notation. I forgot to tell you about this, but basically, the mean is going to be called x bar. Okay, is what we call it, and it's basically just an X with a little line above it. Okay, so that's usually what the mean is. So that's something that's really nice to just be able to calculate. Okay, we do want to talk a little bit about spread and standard deviation, so I do want to bring that up. Deviation. Okay. And I want to go to, and there's a really great place, mathisfun.com, that has a really great standard deviation calculator, and I want to show you this to you. Okay. Alright, this shows you the step-by-step calculations of standard deviation. You want to try it by hand just to work with it. So, a couple of things we need to know. Standard deviation is it's only appropriate for symmetrical data. So if you have skewed data, you don't want to use this as much. But if you do have symmetrical data, you can tell how spread out it is and how spread out we're going to be. Okay, so a couple of things you do need to know is that are you taking a sample? Are you doing a standard deviation of an entire population or a sample? So you have to always connotate that first, and I'll explain a little bit later why. So let's say our numbers are like right here. Let's change this to a +4 just to make it interesting. Let's add some more. Let's go 15, 7, 8. Okay, so there we go. Alright, so we add it. So we're going to keep it as a population. Let's say this is all the numbers in the world, and we just have that. And so let's say this is shoe sizes. Okay. First, we work out the average or the arithmetic. So in other words, we add them all up, and we find that there's 8 numbers. The sum is 60, and we divide by 8, and we get 7.5. Okay, and if we did a box and whisker plot, you would see this is kind of funky. So probably sample is a little bit better to go with. Okay, because that's not everyone's shoe size. Okay, then take each number, subtract the mean, and then square the results. So in other words, we take 6, we minus 7.5, which would be negative 1.5, and then we square it, and we would get 2.25. Okay, and then you do that for each number, and then you add them all up, and you would get 82. Okay, now, if you take that number and then divide it by the count, in other words, the sample, which would be 8 numbers, and minus 1, which would be 7. If you divided this by 7, you would get the variance. Okay? And if we square root this number, we get the actual standard deviation. Okay? All right, so you just have to understand standard deviation and variance are very closely related. Well, shoot, they're practically the same number. Variance is the square of the standard deviation, and standard deviation is the square root of the variance. Right? But if we work it out that way, we can actually find it. Now, here's the complicated formulas that they just did up there, except they listed everything. They just worked it out. Okay? And now that I've shown you what the formula is, what the heck does it do? It's this little, it's a lowercase sigma, okay? And the variance is defined as the average of the squared differences from the mean. Okay, so to calculate this blah, 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 so on, let's explain what it does. Example, you and your friends have just measured the height of your dogs. All right, the heights of the shoulders are these measurements, and then find out the mean, variance, and standard deviation. So, first step is to find the mean. So we add up all the dogs' heights and divide it by 5 because there's 5 dogs in our... Now this is our population of dogs. If we had a whole bunch of dogs, we would go and use just a sample because it's easier. But if we just have 5 dogs in our population, that's population. Okay, and we found out the average height is 394 millimeters. Okay, so that's kind of cool. So you can kind of see that this guy right here, and this guy right here, and this guy right here really close. Are the Dachshund and the larger dog, the Rottweiler, are they really far off? Okay, so now what you do is you calculate the difference. So you subtract the height of the Dachshund with the mean, and you just continue to calculate. And negatives, albeit, are important because they connotate, okay, this guy's underneath, this guy's above, but when we square it, it's not going to change a whole much. Well, it's just going to make it everything positive again. So we square everything, we divide by 5, and we get 21,704. So the variance is 21,704. Well, that doesn't make any sense because if we look at the heights of the dogs, 600 milliliters, that's a lot. Okay, now the standard deviation, we just square root the variance, and we get 147. So 147 millimeters standard deviation from the mean. Okay, so if we take a look at that, 147, this guy's well within standard deviation, this guy's within, and this guy's within. However, this guy's out and this guy's out. So these guys are abnormally small compared to with the rest of the population of dogs of 5, and this guy's abnormally large. Okay, so by using standard deviation, we now have a standard way of knowing what is normal, what is large, or extra small. Rottweilers are tall dogs, and Dachshunds are a bit short. But don't tell them. Okay, but that's basically what standard deviation does, is it tells you, okay, within relation to the rest of the population, what's going on here. You know, so it's really kind of cool how it works out that way. All right, so that is it for standard deviation and working with this stuff. Now we got to talk about some errors that people can make so that you guys don't make the same type of mistakes. Okay. Alright, so some things. What can go wrong? Do not make a histogram of categorical data. Don't look for center, shape, or spread on a bar chart. You always want to do that with a histogram. That's the only time you want to work with it that way. Don't use bars in every display. Save them for histograms and bar charts. Okay, choose a bandwidth appropriate to the data. Computer programs usually do a pretty good job of choosing program bandwidths. Often there's an easy way to adjust with. Okay, just be very careful how you work with the bandwidth. It makes you, the smaller you go, the more data you can see and see some funky stuff. Okay, don't forget to do a reality check. Don't let the computer or calculator do the thinking for you. Don't forget to sort the values before finding the median or percentiles. And don't worry about small differences when using different methods. Finding a 10th percentile or a lower quartile in data set sounds easy enough, but it turns out that the definitions are not exactly clear. If you compare different statistical packages or calculators, you may find that they slightly give different answers for the same data. These differences, though they are unlikely to be important in interpreting data, the quartiles are the interquartile range, so don't let that worry you. All right? Huge thing in statistics, when you're doing standard deviation or variance, know if it's a population or a a sample, because if it's a sample you have to do n minus 1 on the bottom, and if it's a population you just have to use n, and n in this case is going to stand for the amount of data in that set. Okay. All right. Also, don't compute numerical summaries of a categorical variable. So in other words, don't put numbers on there and calculate them. That's not going to help. Don't report too many decimal places. Don't round in the middle of a calculation. Never round in the middle of a calculation. Chaos theory right there. Watch out for multiple modes. So if you have a multimodal equation, you want to be aware of it, and you just want to know that that probably means something. What it means, don't know. It depends on the situation. Beware of outliers. Okay, so the median and the interquartile range are resistant to them, but the mean and standard deviation are not. Okay, don't forget to make a picture, make a picture. You have to make a picture just to see it. Always mess with pictures. Use your graphing calculator. It just helps out immensely. All right, that is it for this chapter. You guys enjoy the test, and if you have any questions, feel free to ask. Thank you. Bye.